This is another example of where we can use systems of equations to solve. 9 batteries are hooked in series to provide a 33-volt power source. Some of the batteries are 3 volt and some are 4.5 volt. How many of each type are used? So what this question is asking is how many of each type of these batteries are being used. The information that we're given is we're given that there's 9 batteries altogether, and by being hooked in series means that we can find the total voltage by just adding all of the battery's volts together. I know the total voltage is 33 volts. Some of the batteries are 3-volt batteries and some are 4.5-volt batteries, and we want to see how many of each. So I'm going to begin by writing what I'm trying to find. So I'm trying to find how many of each type of batteries are used. So I'm going to say, let A equal the number of 3-volt batteries. So not just A equal 3 volt, but A is specifically the number of 3-volt batteries. And let B equal the number of 4.5-volt batteries. I have 2 unknowns, which means I want 2 equations. For the 2 equations, I see that we have 9 batteries and we have 33 volts of power. So since A and B are just the number of batteries, the number of A plus the number of B equals the number 9. There's one of our equations. For the other equation, I know that it has to add up to be 33 volts. So I want the total voltage delivered by all of those 3-volt batteries and the total voltage delivered by the 4.5-volt batteries. If I have one 3-volt battery, that gives me 3 volts. If I have 2 3-volt batteries, that would give me 6 volts, and so on. A way to generalize this would say 3A equals the total voltage from the 3-volt batteries. Okay, so 3 times A is the total voltage from the 3-volt batteries. 4.5B is the total voltage from the 4.5-volt batteries, and that should equal the total voltage of 33. I don't need to do 33 times 9 because that 33 already is the voltage. So what we have here is we have the volts from the one plus the volts from the other should equal the total volts. Okay, now we have our system of equation. We can solve this. Again, I'm going to solve using the elimination or addition method because I like it and I think it's easy. So to do that, I'm going to pick one of these variables, either A or B, and get the opposite coefficient in the other equation. So when I add them together, they become 0. So I think the easiest thing to eliminate is the A's. So what I'm going to do is I'm going to multiply this top equation through by -3. And I pick that -3 because this A in the other equation is positive 3A. So my top equation becomes -3A minus 3B equals -27. And the next line is 3A plus 4.5B equals 33. Now, since one of them is negative and one of them is positive, they add together to be 0, and 0 plus or minus the sum of this, so -3B plus 4.5B is 1.5B equals 6. Divide both sides by 1.5. We will get B equals 4. All right, we know one of our unknowns. We still want to solve the other one. I think the easiest thing to do would be to go back and use this equation right here before we multiplied it through by 9, or -3. So I know that a plus b equals 9. So that means a plus 4 equals 9, which means a equals 5. So there are 5 3-volt batteries and 4 4.5 volt batteries. Thank you.